All right, let's jump right in. Today, we're looking at something pretty wild, a solution to one of the biggest problems in tech. We're talking about an AI data center that actually powers itself. I mean, there's no question, right? AI is completely changing our world. From healthcare to how we do business, it's opening up doors we never even knew existed. It is a huge leap forward, promising to change our future in all sorts of amazing ways.
But, all that incredible brain power, it doesn't come for free. It comes at a cost. A massive, energy-guzzling cost that, honestly, we don't talk about nearly enough. So what is the hidden price tag on this AI revolution?
Okay, to really get a handle on just how big this problem is, get this. A single large AI data center can pump out over 50 megawatts of waste heat. I mean, that is just a staggering amount of energy that typically just gets vented straight into the air. Gone. Pure waste.
But, and this is where it gets really cool, what if we've been looking at this all wrong? What if we could take that problem, all that massive heat, and actually turn it into the solution? What if that heat isn't waste at all, but a resource just waiting to be tapped?
Okay, so first up, Section 1. Let's really dig into AI's insatiable energy problem. We're talking about the huge heat challenge that comes with all this high-density computing.
Yeah, this isn't just one simple thing. It's a problem with a bunch of layers. First, you've got the massive electricity consumption. Then, the specialized chips that do all the heavy lifting. They generate this incredibly intense, focused heat. We're talking over 300 watts from a single chip. And the old-school way of cooling these places, basically giant air conditioners, well, they're super inefficient and have their own big carbon footprint. And here's the kicker. Without rock-solid, robust cooling, these billion-dollar data centers are always at risk of just shutting down.
All right, let's shift gears and look at the solution. This idea of a circular energy system. This is a total game changer, really. It's all about turning that biggest problem into the biggest power source.
So here's the fundamental difference, side by side. Your traditional data center is pretty simple. Power goes in, you get computation and waste heat out. And that heat is a problem. But with this integrated model, you've got power and organic waste going in. You still get the computation, but now that waste heat becomes part of a process to create renewable energy. It goes from being a problem to a resource.
So the secret sauce here, the engine driving this whole thing, is a process called anaerobic digestion, and it's totally natural. Basically, you take organic stuff, like say potato scraps from a factory, or even manure from a local farm, and you put it in a big sealed tank. Then, these little microorganisms just go to town on it. In an environment with no oxygen, they break it all down and produce this awesome renewable fuel called biogas.
And this is what's so cool about it. You end up with this amazing partnership between two things you'd never think to put together. On one side, you have the absolute cutting edge of high-tech, a super advanced AI data center. And on the other, you have this tried-and-true kind of low-tech natural process. But when you put them together, they create this symbiotic system that's way more efficient and sustainable than either one could ever be on its own.
Okay, so how does this symbiotic energy handshake actually happen? Let's get into the nitty-gritty and walk through how this whole loop works, step by step.
Okay, step 1. It all starts with cooling the chips. A special liquid flows over them, soaking up all that intense heat and getting super hot, up to 80 degrees Celsius. Now, instead of wasting energy to cool that liquid down, it's piped directly over to the biogas digester. That heat is the perfect temperature to get the bacteria inside the digester nice and cozy, right around 35 to 40 degrees, which is their happy place. So inside that warm tank, the bacteria get to work, munching on organic waste and producing a ton of biogas. And finally, that biogas is captured and used as fuel for an on-site generator, which, you guessed it, creates electricity to power the data center. It's this beautiful self-sustaining circle.
But hold on, this whole system is way more than just some clever plumbing. What really takes it to the next level is its AI-powered brain. There's a sophisticated AI that's basically the conductor of this whole orchestra, optimizing this really delicate dance between biology and machinery.
Yeah, this quote absolutely nails it. This isn't some set-it-and-forget-it machine. It's an intelligent, adaptive ecosystem. It literally learns from every single hour it's running, using that data to get smarter, more efficient, and more reliable over time.
So this brain is a piece of software called the Anessa AI Digital Twin, and it does a few incredible things. First, it predicts the future. It forecasts things like AI workloads, how much heat is going to be generated, and even what the price of energy on the grid will be. Then it optimizes everything in real time.
It figures out the perfect recipe of feedstock, how many potato scraps versus manure, to create just the right amount of power the data center needs right now. Of course, it's always learning from performance data to constantly improve. And finally, it monitors everything, giving the operators a single dashboard to see everything from the temperature of a specific GPU to the quality of the biogas being produced.
And if that AI software is the brain, you can think of these things called PLCs, or industrial controllers, as the nervous system. These are the tough little computers that take the AI's complex commands and turn them into real-world action. They're the ones opening a valve, changing a pump's speed, doing all the physical work with second-by-second precision to keep the whole system perfectly balanced.
So what's the big picture here? What does this all mean for the future of green AI? Let's zoom out and talk about the incredible impact of creating a data center that could be not just carbon neutral, but maybe even carbon negative.
Well, the number one goal is pretty radical: energy self-sufficiency. I mean, look at this chart. The target here is for the data center to get 80 to 90% of its power from the biogas it makes right there on site. That means it barely has to touch the main power grid, which just slashes its carbon footprint. But what's really amazing is that this isn't just a win for the environment, it's a huge win for the bottom line too. This system basically becomes a moneymaker from a whole bunch of different streams. Of course, you're saving a ton of money on energy, but you can also charge so-called tipping fees to local farms and factories for taking their organic waste. Then you can sell carbon credits for the emissions you're reducing. And that leftover stuff from the digester? It's called digestate, and it's a fantastic organic fertilizer that you can sell. It's incredible.
So when you add all of that up, the savings and all those different ways to make money, the payback period for building one of these things is estimated to be just 5 to 10 years. For a major infrastructure project, that's a seriously good long-term investment.
Which leads us to our final big question. By creating this kind of closed-loop ecosystem run by a smart AI to make it as efficient as possible, could this be it? Is this the blueprint for how we power the future of artificial intelligence in a truly sustainable way?